I'm Gigi.
And I'm Lana, and we're members of the First Tech Challenge Team 12827, the Crazy Cat Ladies.
Hi, I'm Haley and I'm an FTC student. We are so excited for this year's Game Changers season, and we're even more excited to share with you some of the things we've learned in our experiences in First LEGO League. In this video, we will outline the things you need to know about using sensors on your FLL robot. You may ask, what are sensors? Sensors help the robot determine its surroundings and location on the field. If you would like to create more reliable programs, sensors are the way to go. Each sensor has a specific job in giving the robot human-like qualities. The touch sensor responds to physical contact, while the ultrasonic sensor provides distance to a nearby object. The color sensor provides light intensity values or detects color. The gyro sensor provides the amount of rotation your robot has turned. Let's dig a little deeper into the touch sensor. The way a touch sensor works is it gives your robot touch receptors. The button on the sensor can detect when it is being pressed or being released. It can even be programmed to wait until the button is both pressed and released in an event called bumping. When should you use a touch sensor? You might want your robot to move until the button is pressed, released, or bumped. You might also want to have your robot start or stop when the touch sensor is pressed. Now let's show you how to program the touch sensor and what it looks like when it runs on the robot.
This program will wait until the touch sensor is pressed and then it will move forward. I'm going to grab a wait block and I'm going to set it so that it waits until the touch sensor compares its state. I'm going to leave everything like it is. Next, I'm going to grab a move steering block and keep everything like it is, except I'm going to slow down the power. This program will move until the touch sensor is pressed. I'm going to start by grabbing a move steering block and setting it to on. I'm going to slow down the power to 10. Next, I'm going to grab a wait block and I'm going to wait for the touch sensor to compare its state. I'm going to leave everything else like it is with that wait block. And the last block I'm going to use is another move steering, and I'm going to set it to off so that the robot stops. Let's talk about the color sensor. The color sensor can detect the color or intensity of light. It has three different modes: color, reflected light intensity, and ambient light intensity. I'll explain the differences between them in just a minute. On the game mat, you'll find that the color sensor can help you detect the color of a game element, stop at a line, or follow a line. So, when building your robot, be certain to always point your color sensor towards the object or line that you would like to sense. Keeping it closer to the object or mat is better. For best results, the object should be 1 to 2 centimeters away. Also, keep lighting in mind. What I mean by this is try to have a consistent amount of overhead light as you practice. Not too bright and not too dark is ideal. As I mentioned before, the color sensor has 3 modes. The color mode helps the robot distinguish between up to 7 different colors with corresponding numeric values. 0 equals no color, 1 equals black, 2 equals blue, 3 equals green, 4 equals yellow, 5 equals red, 6 equals white, and 7 equals brown. Reflected light intensity means that the color sensor emits a red light and measures the amount reflected back to itself from the surface you are testing, in this case the game mat. The intensity of the light is measured as a percentage from 0 to 100. 0 is very dark and 100 is very light. In ambient light mode, the color sensor measures the amount of light in its environment without providing its own light source. It is also measured in the same way as reflected light intensity. Have you ever wondered why the FLL game has so many black lines that look like paths? Well, you can program your robot to look for them and follow these lines, which will make your programming reliability so much better. Using reflected light intensity from a downward pointing color sensor to follow the edge of a line on the game map. The robot should try to keep a balance between white and black, turning one direction when it sees more white, reflected light intensity greater than 50, and the other direction for black, reflected light intensity less than 50. Let me show you how to program the color sensor to follow a line, and we'll watch the robot execute the program. I'm going to go into the flow control folder and I'm going to grab a loop. I'm just going to leave it at unlimited. Next, I'm going to grab a switch block and put it inside the loop. And I'm going to set it so that the color sensor compares the reflected light intensity. And I'm going to set it, I'm just going to leave it as it is. I'm going to put a move steering block in the upper compartment, and I'm going to set it to on, and I'm going to have it turn -10, and I'm going to set the power to 10 so it doesn't go too fast. Now in the lower compartment, I'm going to put another move steering block. I'm going to set it to on again, and this time I'm going to have it turn right 10, and I'm also going to set the power to 10.
Next up is the ultrasonic sensor. The ultrasonic sensor measures the distance to an object to a maximum of 255 centimeters or 100 inches away. It accomplishes this by sending out high-frequency sound waves that bounce off any object that is in the robot's range and measures how long it takes the sound to return to the sensor. You can think of it as working like sonar. You can select whether the distance given is in centimeters or inches while you program it. Be certain to check on this, as oftentimes if the ultrasonic sensor appears not to be working, it's because the measurement unit is not set as you intended. When can you use the ultrasonic sensor? One great way is to stop the robot when it's a precise distance from the game table wall without actually touching it. Let me show you how you could program this and what the robot looks like when performing it.
I'm going to grab a move steering block and set it to on so that the robot starts moving forward. I'm going to set the power to 10 so that the robot doesn't move too fast. Next, I'm going to grab a wait block and set it so that it waits for the ultrasonic sensor to compare the distance in inches. I'm going to set it to less than or equal to, and I'm going to set the inches to 3. Next, I'm going to grab a move steering block and set it to off so that it turns the motors off.
Last but not least is the gyro sensor. The gyro sensor is able to provide angular velocity of the robot, but usually you will just use the angle measure positive for clockwise, negative for counterclockwise. One way to think about the gyro is that it essentially functions as a compass. We haven't discussed troubleshooting yet, but with all the sensors, if you expect they are not properly functioning, unplugging them and plugging them back in usually helps to reset them. However, the gyro calibrates what it considers to be still. When the gyro sensor is connected or the EV3 starts up, if the robot calibrates incorrectly, while the robot is moving, for example, you must recalibrate to avoid getting bad data, called drift, from the sensor. So remember, don't touch the robot or lean on the game table as you calibrate your gyro sensor. By resetting the angle for your gyro sensor, you can measure the rotation from a desired starting position. Like, if the robot should turn a precise amount, you can turn it until it reaches the right amount of rotation from the gyro sensor. Let's look at how to make a program that uses the gyro sensor.
I'm going to go into the sensor folder, and I'm going to choose a gyro sensor block. Now I'm going to set it to reset so it starts at 0. Next, I'm going to grab a move tank block and set it so that the robot turns to the left. Next, I'm going to grab a wait block so that it waits for the gyro sensor to compare the angle and that it is less than or equal to -45. Next, I'm going to grab another move tank block but set it to off so that the robot stops completely.
I hope you found this video helpful. As always, learn more about First LEGO League at www.firstinspires.org. Thanks for watching!